Okay, hello class. Good afternoon. Thank you very much for joining EGT 231 once again. So this is the second day of this week that we're going to discuss more about Chapter 7, in particular, internal resultant loadings. I just want to go over probably two more examples from Section 1, and then we'll move into, actually that's Section 2. Then we're going to move more into Section 3 and 4. Okay. So when you look at your textbook, page 324, number 15, so we have a problem here that asks or states that the beam supports the triangular distribution load as shown. Okay. And they want us to determine the resultant internal loading, the cross section at point C. So point C right here. Assume that the reactions at the support A and B are vertical. Okay. So our for our solution, step number 1, you always know to draw a free body diagram. Okay. And in doing so, we've been told that A and B are vertical support reactions, right? So we can just draw a beam. AY, say here BY. Okay. And we know at B, this triangle here. Okay. So at this location, and this is 800. That is 800 pounds foot. Okay. So this right here is 800 pounds foot. Okay. And we can continue further. So right here we have two triangles that are connected at this point here. Okay. So now we want to be able to find the resultant force of each triangle. Now mind you, at point D, so point here, point here, just put our span. This is 6 feet, 6 feet, 6 feet, 4.5 feet, 4.5 feet. Okay. Now we want to be able to find the resultant load of this particular triangle here. Let me just use another color. And find the resultant load. It's going to reside either 2/3 from the apex or 1/3 from the base. So it's going to reside at this location here. That'll be the resultant load, 2/3 from the apex or 1/3 from the base over a span of 18 feet. Okay, so because we're looking at this triangle. Okay, so let me draw another color. So now this is going to be 1/2 the base, which is 18 feet, times the height, which is 800 pounds feet. Okay, and that value gives us 7,200 pounds. Okay, now we have another resultant force, and I'm going to erase this. It's in the way. Okay. We have another resultant force is going to act 2/3 from the apex or 1/3 from the base. Okay, so in this case, I'm going to slightly erase this part. Okay, because we want 2/3 from the base. I mean, 2/3 from the apex and 1/3 from the base. I could just redraw this. And we're going to have something like this. This is going to be 3 feet, 6 feet. And our resultant force of this triangle load is going to be at this junction here. Okay, because we have 1/3 of 9 is 3. 1/3 from the base. This is the base. This is the base right here. This is the apex right here. So we're looking at this triangle right here. Okay, 1/3 from the base. 2/3 from the apex. 2/3 from the apex equals 6. 2/3 times 9 is 6. Okay, so get rid of this right here. Okay, now this is going to be 1/2. The base is 9 feet and the height is 800 pounds-foot, which is going to give us 3,600. Okay. Okay. With that being said, let us move forward, and we want to be able to find our support reactions. But mind you, now we're going to do essentially looking for the internal load. We're going to do a cross-sectional cut. So it would be, and we have to do a cross-sectional cut at point C. So C is around here. Okay. So when we make a cut here, let me use another color. If we can make a cut here and separate it to our left and to our right, but you notice that we will have almost like a trapezoid on this end. Okay, if we separate it, and then we have this extra triangle on this side right here. So that's extra work, right? So we might as well just, after you make a transitional cut, as I expressed in my previous video, you can either take the left or the right. It'll be best to take the left side because you have a straight triangle. The only thing is we have to be able to find out what's this height right here. Okay, so let us first of all take care of finding the resultant or the support reaction of AY. So if that's the case, we want to be able to find some of the moments about point B equals 0. Okay, and in doing so, you're going to get AY times 18 feet minus 7,200 pounds times 6 feet. Okay, plus 3,600 pounds times 3 feet equals 0. My AY equals 1,800 pounds. Okay. So now what I want to do is I want to take a cross-sectional cut, and I'm going to take the left side, as we said before. Okay. And when I do that, so step 2, this is chapter 7, section 1-2 exercises. Okay. Make the cut. Make cross-sectional cut. And take left figure. Easier. Okay, so in doing so, I'm going to just come here, and this is my cut at C. Made this cut right here. Okay. Now I have to be able to find. So I made the cut right here. I have to be able to find this height though, because I don't know what that height is. Okay, and this is my A sub y. Okay, and we are going over a span. We are going over a span of. Okay, let me just go over a span of. We're going over a span of 6 by 6. So it's going to be like this: 6 feet, 6 feet. Okay. So we need this height right here. Okay. So the first thing we can do is, we know that if we were to extend this, this is 800 pounds foot, right? If we were to extend that. Okay, so we can use the similar triangle technique, whereby we know that this right here, of course, is 6 feet. So it's going to be, we have a larger triangle, actually a smaller triangle within a larger triangle. So this would typically be the larger triangle going across this way, and the smaller triangle will be from here going on in. Okay, that's a smaller triangle. So the larger triangle will be 800 pounds foot. You want to divide that over a span of 18 feet equals, we want to be able to find this x right here, that height x over, and this triangle is over 12. 6 and 6, 12. When you solve for x, you're going to get 533.33 pounds per foot. Okay, so I can erase this part right here. Oops. I can erase this part right here. Erase all of this right here. Okay, I'm just trying to get this thing to erase. Okay. Okay. And then, okay, so we can come back here. Use our green marker. This is 533.3 pounds per foot. Okay. So we found that height. Now we have to be able to find the resultant force of this particular load distribution. So this load distribution is triangular. So therefore, you have to find your resultant force, again, which is 2/3 from the apex, 1/3 from the base. And when you do that, you're going to get, use another color, it's going to be from here to here is 8 feet, and from here to here is 4 feet. Okay, and this is going to be this is going to be 1/2 times 12 feet times 5, 33.33, and that's going to equal equivalent to 3,200 pounds. Okay, so once we've done that, now don't forget that at C, this point C, we're going to typically have what you know as our normal force at C. We're going to have our shear force at C, and then we have a moment at C. Again, this is our point C. Okay. Now these directions, again, you go back over. If you have, I showed you, you make a cross-sectional cut, and then you look at internally what's going on. So you use that go back to the guide that I gave you in the previous lecture, so that you can look at how, again, this is on the left side, so I'm choosing the left side of the structure. Okay, so this is parallel with this. Okay, and then if I do the shear and I make a transitional cut, okay, that means I'm going up this way, I'm coming down this way, going up this way, coming down this way. When I make a cut, coming down this way, and I'm going down this way. Okay, so they're always opposite each other. Okay, so I'm taking this side. So this line right here, this shear force coming down, is parallel this shear force coming down. I'm taking the left side. Okay. 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 Yeah. Okay. So, oops, I'm supposed to do that. Okay. So after that, so now you know. So now we can take the moments about point C. Okay. And that equals, since that's going to be negative MC plus our AY times 12 feet minus, 3,200 pounds by 4 feet equals 0. And then you can solve for MC. M sub C, you're going to get pounds foot. Okay. Now some of the forces about Y direction equals 0. You have AY minus 3,200 pounds minus V sub C equals 0. V sub C happens to be negative 1,400 pounds. And all this typically means is that the direction I chose should be the opposite direction. So in actuality, my shear force should be like this. Okay, that's all that means. And that goes back, that will go to a plus, because this will be a plus. Okay. Okay. Then some of the forces in the x direction equals 0, and there's no forces in x direction. That's going to be NC equals 0. Okay. So I hope you understand how that works. Okay. Let me stop here, and I'm going to pick up from another video. Okay, thank you very much.